On the barren expanse of Mercury's surface, where craters dominate and tectonic activity is virtually non-existent, an unexpected enigma unfolds. The planet boasts a magnetic field, a celestial anomaly that defies logic. Join us as we embark on a cosmic journey to unravel the mysteries of Mercury. NASA's persistent exploration since 1974 has recently yielded captivating images through the BepiColombo mission, offering us unprecedented insight into the hidden realms of this seemingly desolate world. Stay tuned to unveil the secrets that make Mercury, against all odds, a cosmic marvel. Before we jump into the video, let me tell you some fun facts about the planet Mercury. Mercury is the smallest of all planets in our solar system, and also the closest to the Sun. The Sun appears 3 times larger when viewed from Mercury compared to when it is viewed from Earth. Therefore, the sunlight is 11 times brighter on Mercury, yet despite being so near the Sun, Mercury isn't the hottest of all the planets. It is Venus that is the hottest of the planets due to its dense atmosphere. Temperatures on Mercury can vary greatly depending on its side. The side that faces the sun can get as hot as 800 degrees Fahrenheit, while the night side can get as cold as negative 280 degrees. Mercury got its name from the fastest of the ancient Roman gods. This is because the planet orbits the sun in only 88 Earth days. Hence, 1 year on Mercury equals 88 days on Earth. The planet is also slightly larger than our moon, and just like the Earth's moon, it's covered with tens of thousands of impact craters. Some experts suspect Mercury has water ice on its surface. It's hard to know for sure because some craters are so deep that they are always in shadow, even when it's daytime. They probably stay cool all day long, considering there is almost no atmosphere on the planet. Scientists have been puzzled by the strange behavior of Mercury for many years. Despite its minuscule size, it possesses a disproportionately massive core. Astronomers cannot explain Mercury's anomalies when simulating the formation of the solar system. One of the most mind-boggling facts about Mercury is that it has a magnetic field. Although it's only 1% of the strength of Earth's magnetic field, it is still inexplicable. Planets normally have the heaviest elements of the planet in their cores, such as nickel or iron. Cores are responsible for generating magnetic fields. When these cores are in molten state due to high temperatures, the metals within them melt. As the planet rotates, the hot metal cores move, making the conditions for a magnetic field. However, Mercury does not possess a substantial molten core. Due to its small size, the inner core has fully cooled and solidified. However, the outer core still has a small amount of liquid even though it's not very big. The bizarre discovery of a magnetic field on Mercury was made during the Mariner 10 mission in 1974. Many scientists believe that the unusual characteristics of Mercury are related to the giant planets. Mercury, the second densest planet in our solar system, is much smaller than Earth. It has only 5.5% of Earth's mass and volume, but its density is 98% of Earth's. Mercury possesses an extraordinary density due to its expansive core. It extends to approximately 85% of the planet's overall radius. In contrast, Earth's core is only about half of its radius. Astronomers have struggled to explain why Mercury is so small but has a huge core. They've been trying to figure it out by making simulations of how the solar system formed. Our current simulations can give us a basic idea of how the inner planets formed. This process took about 100 million years. Small planetesimals collided to create the planets we see today. The simulations accurately determine the number of inner planets and their characteristics. They show that the planet orbits are elliptical. However, these simulations often struggle to accurately predict the masses of the inner planets, particularly when it comes to explaining why Mercury has a disproportionately sized core. Astronomers recently published a paper in the journal Icarus trying to solve Mercury's puzzle. Despite not fully understanding Mercury's characteristics, they made significant progress compared to previous teams. They believe their findings show a promising path forward. The primary objective is to explain why Mercury is so small. The lack of enough building materials in the protoplanetary disk during formation caused this. That eventually led to the creation of planets around the young sun. Research shows that protoplanetary disks are thinner toward their inner edges. This is a result of the force and pressure from the star at its core. Consequently, Mercury was not endowed with abundant resources from the outset. The outer planets didn't originate where they are now because there wasn't enough material there to form them. As a result, they had to form closer to the sun where the gas density was highest. Once they formed, the planets began pulling on each other with gravity. This went on for millions of years until they settled into their current orbits. During their simulations, the researchers found that the interaction of the outer planets resulted in less material in the inner disk. This depletion included the removal of any existing small amount of material. Even though they are far from Mercury, the huge size of the giant planet still affects the inner disk. These small gravitational pulls have the ability to direct material toward the Sun or even expel it from the solar system entirely. Mercury's size was predetermined to be small due to its incomplete formation. During the initial stages of planet formation, Mercury shared its orbit with numerous other celestial bodies. Although many were removed from the inner solar system by the gravitational forces of the outer planets, some remained. Afterwards, some collisions occurred. When Mercury was young, it had many destructive collisions with similar-sized objects. These collisions were capable of disintegrating lighter rocks. The only remnants were the heavier components that constitute planetary cores. Each collision added mass to Mercury's core, but not to its lighter mantle and crust. The researchers' model doesn't fully cover the whole situation, even though it may seem logical. However, the outcomes are still considered as progress. It is now evident that the giant planets had a notable influence on the formation of the inner solar system. Mercury's core developed through collisions made possible by eliminating substances from the inner protoplanetary disk. Although Mercury is not very interesting, there are still fascinating things about the planet. For example, it has a magnetic field and a surprisingly large core. For these reasons, space explorers have been watching Mercury up close since 1974. Mariner 10 was a NASA space probe that was launched on November 3, 1973. It was the first spacecraft to visit Mercury and Venus. In 1974 and 1975, Mariner 10 flew past Mercury 3 times. It took close-up pictures and collected important information about the planet's composition, geology, and magnetic fields. These findings helped us learn more about the inner solar system. After Mariner 10, NASA launched the Messenger spacecraft. It became the first spacecraft to orbit Mercury. Messenger was launched on August 3, 2004, and it entered orbit around Mercury on March 18, 2011. During its mission, Messenger collected a lot of new information about Mercury. This included details about the planet's composition, geology, magnetic field, and its thin atmosphere. It also studied how Mercury interacts with the solar wind. This year, European-Japanese mission BepiColombo completed its third close flyby of Mercury. The joint mission that launched in 2018 is approaching the final stretch of its 7-year voyage through the inner solar system. The probe shot fascinating images of the planet's surface, which were released in June. The spacecraft flew within 150 miles of Mercury's surface, unveiling a plethora of craters, ancient volcanic ridges, and lava flows. The images also revealed a crater that just received a new name, Edna Manley, named after a Jamaican-British artist who died in 1987. It provided valuable insights into Mercury's early carbon-rich crust. The spacecraft found the Beagle Rupees Escarpment, a 370-mile-long cliff on Mercury. It formed billions of years ago when Mercury cooled and contracted. Scientists have observed ancient impact basins on Mercury that were flooded with volcanic lavas. This suggests that the planet had a long history of volcanic activity in its early years. The way the cliffs on Mercury's surface interact shows us how the planet's surface has moved over time. This also proves that the idea that the planet is completely still is wrong. The BepiColombo mission has 2 orbiters stacked on top of each other. Some instruments are still hidden during the mission. The spacecraft sends home postcards with monitoring cameras during its journey. It has sent postcards from previous flybys and will do 3 more Mercury flybys. BepiColombo plans to be captured by Mercury's feeble gravity in December 2025. This will happen after 3 more flybys around Mercury. The mission will keep releasing energy until it reaches a captured orbit around Mercury. It still remains a mystery how the planet manages to have a magnetic field. As Mercury guards its magnetic secret, the cosmos awaits more revelations. Join us on our cosmic journey, our gateway to the wonders of the universe.